Alright, part 2 here. Pretty much the same thing, except for now you're going to see that we don't have a set domain, meaning you're going to be able to make some choices, and it will be important that you make enough choices so that you can see the shape of what's going on. Again, I would recommend solving for y. This one, A, is already solved for y. If you're more comfortable seeing it like this, you can write it just like that. That would be fine. That's the way I do it. I like to go left to right with y on the left. So just one of my OCD things, I guess. Alright, now you want to make sure you have enough points to check and make sure you can see the shape like I had mentioned. So for instance, I'm going to choose some easy points here. I'm going to start with 0, 1, and 2. If I put 0 in for x, I get 2 times 0, which is 0, plus 1, which is 1. So 0, 1 is a point. If I put 1 in, I get 2 times 1 plus 1 is 3. So 1, 3. And then 2 times 2 plus 1, 5, so 2, 5. Alright. This happens to be a straight line. Now if you wanted to be extra careful, you might throw in a negative just to see what happens. So 2 times negative 1 is negative 2, and negative 2 plus 1 is negative 1. So negative 1, 1 is also there, but you're going to see that that's going to fit on this line as well. And now this is going to continue forever in both directions, okay? Because remember, we don't have a set domain. Sure, you chose these 4 points, but there's much more going on than that. I could have put in 0.675 for x if I wanted to. Now, I don't choose to put that in there because that'd be a tough point to figure out. Not really, but you know, tougher than the ones that we chose. But that would be over 0.67 and up to some point on there that would correlate to that. So you can put in anything for x here. There's no limitation to it. And you can discuss what the domain and range would be. The domain is all real numbers, as my graph will hit every x value as it extends outwards. And my range will be all real numbers as well, because it's going to extend up and down forever as well. And lastly, in a y equals x squared graph, this one, whenever you see your variable to a power, you want to be careful, and you want to throw some negatives in there too. So here's what I'm going to do. I'm going to go 2, 1, 0, negative 1, negative 2. And we're going to find those 5 points. Alright, so if I put 2 in for x, I get 2 to the second, which is 2 times 2, or 4. If I put 1 in for x, I get 1 to the second, or 1 times 1, which is 1. 0 to the second is 0. Negative 1 to the second power, so that's going to be negative 1 times negative 1, gives me a positive 1. If I do negative 2 times negative 2, I'm going to get positive 4, because 2 negatives multiplied gives me a positive. So now here's what this graph is going to look like. Over 2 up 4, over 1 up 1, 0, 0. You can already see just by these 3 points that we don't have a straight line. Negative 1, 1, and negative 2, 4. And we get kind of a shape like a U, or a parabola is the, I know we've seen these before, but this is what we call a parabola. And if we wanted to discuss domain and range, my range would be y greater than or equal to 0, because it doesn't go below 0. It's only everything from 0 on up. So it will continue to rise. And then we want to discuss domain, usually the first one we look at. Will this extend outward forever? It will. It'll just take a while for it to extend. So domain, all real numbers. But mainly this is just about graphing functions. And this is a function. It passes the vertical line test. So that's all I've got for you.